Good afternoon, everyone. Apologies for the late start. We were having a little bit of technical difficulties on our end. We do appreciate your patience, though. So thanks for joining us for today's webinar, Introduction to CHAZOPs. My name's Nancy Murray, and I'm the Marketing Manager here at Autopro. Before we begin today's presentation, I'd just like to take a minute to run through a few housekeeping items. For those of you who aren't as familiar with Autopro, we're an engineering firm specializing in instrumentation, electrical, and controls engineering. We've been in business for almost 30 years now and have offices across Western Canada. We offer end-to-end product management from pre-feed all the way to commissioning and startup on a wide scope of services, including brownfield DCS and PLC migrations and upgrades, greenfield builds, burner management systems, terminal management solutions, safety instrumented systems, alarm management. That's just a few of the areas where we're able to help. But you can also feel free to visit our website at autopro.ca if you're interested in learning more. Some quick introductions. Sam Cosma will be doing the main presentation today. He's a safety and control system specialist here at Autopro, and he's going to tell you a bit more about himself when I turn things over to him. And as I mentioned earlier, I'm Nancy Murray, and I'm the marketing manager at Autopro, and I'll be looking after things behind the scenes today for you. So just a couple of logistics. We're not using webcams, so you don't need to worry about turning your webcam on. Phones are automatically on mute, so we won't be able to hear anything that's going on your end. And we will have some time at the end of the presentation for questions. So I'll just quickly run through how that's going to work. On your screen, you should see a control panel that looks like this. If you're not seeing it, that probably just means it's been minimized, or maybe it's showing up on a different monitor if you have multiple monitors connected. But if you're not seeing it, just look on your screen for this small bar with the 4 buttons on it. And if you click on the little orange arrow at the top, that'll pop out the full control panel for you. If you need to ask a question either while the webinar is running or at the end during the Q&A session, you can just type your question into the questions tab where the arrow is showing. And if your question is just directed to me, if it's a technical issue you're having with seeing something or hearing something, I'll respond back to you and the answer will show up just above here. If it's a question during the Q&A part, what will happen is I'll read the question out and then Sam will answer it so that everyone can hear. At the end of the webinar, a feedback form is going to pop up. We do appreciate if you take a few minutes just to complete it. It gives us a little bit of feedback on how we did today, how useful you found today's webinar. And our webinars also qualify for professional development credits. So you will be receiving an email this afternoon or tomorrow with a certificate of completion that you can keep in your records. And that'll also include a link to a web page where you'll be able to rewatch a recorded version of the webinar. So with that, I'm going to turn things over to Sam. The slides are going to just disappear for a second while we switch over the presentations, and then Sam will take it away from there.
Good afternoon, everybody. It's Sam Cosmo. Thank you very much for coming. We'll talk about CHAZOPs today. As Nancy said, I'm a safety and control system specialist here at Autopro in Calgary. I have over 25 years of experience in automation and process functional safety, and I'm a member of several committees, notably the 61508 on the international side. Here in Canada, the Standards Council of Canada, the technical or the Task Force on Functional Safety, the IEC 61511 Mirror Committee, and some others. And I'm also on a CSA committee, electronics or functional safety involving electronics. So our agenda today. So because CHAZOPs are very similar to HAZOPs, we'll review what a HAZOP is. We'll go into high-level detail on it. We'll introduce the CHAZOP concept, go through the process, and as well as some goals and expected goals and outcomes. And then, as Nancy said, at the end, we'll have some time for discussion and questions. So a HAZOP is essentially just a hazard and operability study We identify what process and hazard operational hazards through a systematic approach, and we design, or we fail the design at different aspects. So we'll find causes and to see what happens. And the idea is to figure that out before before construction. The primary goal is to improve the design and operational efficiency as much as possible. So again, the potential risks can be revealed during the process design and not after. So on the left side, we take a look at a pressure controller there, and if that pressure controller does not work, what happens? And if the consequence and the severity of that is high enough, then on the right side we might have to add some ESD valves. So as an example, so oops, my apologies, mouse is touchy. So again, we use the hazard matrix and identify what the causes and consequences are. We determine how severe they are, how bad, and how likely they are to occur. And again, we develop what the risk is. We apply safeguards to bring that risk back to a tolerable level. So again, we start off with something in the orange or the red, and then as we apply the safeguards or layers of protection, we can reduce the severity and the likelihood. So the outcomes. So we identify what the operation and process causes. We develop the consequences of those. We rank them as we saw before, and with the safeguards applied in order to be able to control the risks associated with the process. And out of most CHAZOPs come a number of recommendations, all designed to improve efficiency, improve operations, potentially even saving money on construction and long-term operating costs. So the CHAZOP goals, again, just to review those, so improved operability, improved maintainability, that's important. Potential capital expenditure and operating expenditure savings throughout the life cycle of the facility, and of course improved safety and reliability. So why do we CHAZOP? Well, in a nutshell, because we have to, or we really should. A lot of insurance companies are actually making sure that those are being done now. It does save money. It's a chance for operations to sit in on the CHAZOP sessions, provide feedback to the engineering and the design team, excuse me, and provide some feedback and some lessons learned. For example, and engineering, we put a skid out in a pump skid and figure that we're going to operate it a certain way, and the operators, have a different way of operating it. And it could cause a cavitation hazard. So through the discussion and through the CHAZOP, we can identify that through feedback from the operators, and be able to correct the design, to be able to give the operators what they want and what they need to operate efficiently and effectively, without causing or creating a risk to themselves or the facility. So that's a general overview of a CHAZOP. And again, it's fairly high level. But a CHAZOP is essentially the same thing, except it's specifically centered around the control system. So again, it's a systematic approach to failing a control system design. And what are the effects? If we lose a CPU, or we lose an I/O module or a power supply, what happens? Again, the primary goal is to improve the design as much as reasonably practical, to improve operations, maintenance, safety, reliability. So a CHAZOP normally considers a control loop, for example, like in our first example, we talked about a pressure control loop, and a CHAZOP will consider that as a failure. Where a CHAZOP will focus in on just the controller itself and the I/O associated with it, and not the field equipment. So we take a systematic walkthrough of the elements of the hardware, and we can go into the software. So if we do the software, we can go through the control system, the different networks from the field all the way up to the corporate network. What happens if we lose servers, and we can also look at third-party interfaces to determine what effect they have on the system, and if they're important, then we can look at the design and the connectivity. With software walkthrough, we can look at critical loops and critical trips to determine how they're being operated, how they're different, what effect different operational modes or different operational parameters will have, not only on the loop or the unit, but the overall facility. So for a hardware walkthrough, we take the walkthrough generally starts with the system architecture. We use the bill of materials to start identifying the components that we want to fail and see their effects on the overall system. And as we walk through, we start walking through different network layers. And we look at segregation and redundancy if that's required, and we also look at power supply feeds, whether they're redundancy or whether redundancy is even required. So we utilize nodes much like a CHAZOP. So we break down, and we start generally with the architecture drawing, and we'll break it down into different nodes. Whether it's by network layer, it can be by process system, it could be by system, whether it's a DCS, foreign device, shutdown system, remote like through a SCADA or a wide area. And then we identify causes based on guide words or what if questions, or even an FMEA component analysis. Again, same as a CHAZOP. So what if our CPU fails, or what if a network switch fails? So as an example, we can break down an architecture into, for example, in node 1 would be the operator stations and the server and the network, everything associated inside of the control room. And node 2 would look at the field equipment, so the CPU, the I/O modules, the power supplies, and then the third node in this example would look at remote devices like third-party interfaces or skid packaged PLCs. So as an example, for power feeds that are studied, so we did look at a power feed on a brownfield control system. We were doing an upgrade, and the plant had several modifications and additions over the life, which all plants do, and things were added, things modified, changed, grew. And so through one of the upgrades, where we thought we were having a power feed designed as redundant, and we thought was installed as redundant, we used an FMEA approach to identify the different components of that and failed each element. And through that, we discovered that there was a single point of failure from the original design. So we hadn't had an incident, or the plant hadn't had an incident to date, but the potential was there. And it would have been, if that component had failed, it would have been a complete plant shutdown, lost production, you know, and maintenance and everything to get back up and running again. So, so the CHAZOP was able to identify that issue. So with a software walkthrough, we don't do it on every single loop or every IO, but we'll identify what the critical control loops or logic and narratives are. Critical safety trips, we can also do it on that. For example, a HIPS, for example, would be considered a critical trip. We look at logic and flow, data flow paths. So passing data from one CPU to the next, or through concentrators, or however the data flows, we can take a look at that and identify those networks and determine whether there's adequate design and hopefully redundancy. We can also look at the operator and console interaction. How are the operators going to use it? How can we make it easier and simpler for them? For example, oh, I just lost myself again here. So for example, inputting a speed set point. You know, I've seen where, you know, you're trying to enter a speed set point of say 7,000 RPM and a zero is missed. So your turbine is running at 6,500 RPM. You think you're increasing it to 7,000, but 700 gets entered in and results in a plant shutdown. So those are types of things that we can identify and help. And in that case, we put ramp buttons in, and we also put set point limits in, so that we couldn't you couldn't step change more than, you know, 100 RPM at a time to minimize the risk of that. So again, when we identify our critical control loop, from our example as a pressure controller, we have, so we're asking questions about how is this loop operated? How is it different, or is it from similar loops? From the outset, it looks like it's just a simple pressure controller, but is it different? Are there any special considerations like ramp rates or set point limiting or tracking or anything, any other interactions with other systems? What are the critical elements? And what if they fail? And what if and do we consider redundancy? Should we have redundant transmitters? Should we have redundant IO modules, redundant CPUs? What data is communicated? Where is the set point coming from? Where is the information being used, and where does it go? And do we have other modes of operation, such as a startup or a batching application? And we even look at local and remote control for unmanned facilities. So again, like a CHAZOP, we risk rank. We look at how bad and how often determines our risk, and then we apply safeguards. And then with our safeguards in a CHAZOP, a lot of them are going to be centered around operator action, and the operator will be given multiple safeguards, which doesn't exactly follow the same rules as a CHAZOP or a layer protection analysis. But it does identify a process and a procedure of what to do if they come across a certain failure or a certain problem. So as an example, so we had way back when there was we're adding a new unit to a new facility. Facility was commissioned like 6 months prior. We were adding in an acid gas compressor, and with the pump off the suction scrubber, it was decided that we would communicate that from one PLC to the other. Well, the communications between the two PLCs failed, and the request for the pump start didn't get through to the MCC, we had liquid carryover to the compressor. So luckily we didn't have an incident, and there were other contributing factors to the issue. There was also a shutdown fail due to design error. But these are issues that can be revealed and corrected through a CHAZOP. So the investigation for that, I think, was about 2 solid weeks, and this incident could have been, or this situation could have been CHAZOP'd in about 20 minutes. So the CHAZOP outcomes, again, very much similar to a HAZOP. So we identify on the control system side the potential failures and causes of the failures. We develop and understand what the consequences are. We identify what a typical response would be, how to identify it, how to respond to it, how to get the process back up and running as quickly as we can. We also rank our hazards and develop recommendations as well. Again, very similar to what a HAZOP does. So some worksheet examples here. So I talked about 3 general types of CHAZOP methodologies. A guide word, again, for anybody who has sat in on a HAZOP, this worksheet will look very familiar. And quite often this would be documented inside of a PHA Pro program, exactly what most HAZOPs use today. So this is, again, we just work through the causes, define the consequences, rank our risks, develop our safeguards, and then we can rank after safeguards to determine how effective they are, and then any recommendations that come out of this for follow-up after the study. The second method that's commonly used is a what if. So we ask a lot of questions, and it's generally used with systems and processes that are well understood. For a HAZOP, we would do it on boilers or other processes that are a well site, for example, or a typical well site. We can do a what if on that. So same with this. If you have a DCS that's standard throughout your corporation, we can start asking just what if questions, so that we only are asking we know what the failures are of an IO module. We can just ask what effect does that have on this particular process or this particular process. So there's several ways to document, and again, this is more along the lines of what would be done in PHA Pro, but you can document it as meeting minutes as well. The third method that I'll talk about is an FMEA, so failure modes and effect analysis. So we basically take the bill of materials and break that down according to the architecture drawing that we've noted it, and then I combine this with guide words so to prompt the questions, and we follow this through. And this sheet, we're looking to see if things are redundant. So we're looking for our failure of our equipment. We have our consequence developed. We know we can identify if it's a single point of failure. If it is it important? Do we need a recommendation out of it? We can develop safeguards, and again, recommendations that come out from after. This is really useful for hardware evaluations, for strictly just going through a system bill of materials. So for a CHAZOP study, it may incorporate more than one method. There may be parts of the plant or parts of the process that or the control system that are well suited to a what if study. There are others that might be well suited to an FMEA. So the method chosen like as part of the CHAZOP preparation to make sure that to determine the best method for the area to achieve the best and most complete results. So other CHAZOP outcomes. So we're just trying to have a better understanding of what our control system is, how it behaves under either full or partial failure. We can identify areas where there could be potential for operator error. And it's not that we have bad operators, just sometimes, again, just, typing in 700 instead of 7,000 is an easy mistake to make, especially when we're in high stress situations. If we understand our control system better and what to do if it fails, it also helps to increase the confidence in our systems. Again, we identify what the single points of failures and what are their effects. And in some cases, it's okay to have a single point of failure and it's not a big deal. In other cases, it is a big deal, and adding a little bit of extra hardware and a little bit of extra design up front could save a plant outage and possible damage to equipment. We can also understand if we have, especially in older PLC systems, do we really have true redundancy, or or is it hot or a cold or a cool standby? We can identify potential IT issues. So through our network, often our control systems are linked to our corporate networks. So we identify potential interface areas and areas to coordinate with corporate IT, all to try and keep the control system network as secure as we possibly can. We can identify some cybersecurity issue, although the CHAZOP is not a cybersecurity assessment or an audit. We can and we do ask some questions about network intrusion, not necessarily malicious, but maybe unauthorized, and what happens in terms of a partial failure where we might get a network storm. We can identify potential intrusion points and what can we do to prevent that. Sometimes it's just mechanical lockouts on network ports and access, login IDs. We can identify potential communication and network issues. But again, I need to stress that the CHAZOP is not a cybersecurity auditor or an assessment, but it can identify the need for one. As for timing, so for Greenfield, there's two major types of CHAZOPs. So there's a course CHAZOP, which we would do during the feed. We would typically look at a block diagram of the architecture, a very high level. How is the power coming in? What redundancy schemes are we looking at? Do we need? And then later on through the detailed engineering, we would do a detailed CHAZOP where we're actually looking at I/O modules. If we're looking at software, we would look at critical trips and critical control loops. So both of these would happen ideally approximately the same time as the process CHAZOP would, maybe just following by weeks, or depending on the size of the project, it might be a month or 6 weeks after. On a brownfield, we can do a CHAZOP prior to an upgrade. We can do it as part of to determine what's already there. Again, it would be similar to a greenfield, a full design on a greenfield. We've been asked to do them after an incident to try and help determine root cause analysis, and to also to help identify improvements that can be done throughout the facility and even throughout the on a corporate-wide basis. So why do we HAZOP and why do we CHAZOP? Well, the whole goal is to fail the design on the table and not after construction. The design changes that are identified and completed early are generally minor. The longer we leave those changes, those corrections become major issues impacting the schedule and budget. And almost always, our risk studies will almost always find some type of efficiency. So in a study I was involved with, a design posed more risk than the team was reasonably willing to accept. We kept coming up with the same result, and we studied the same situation scenario over about 2 or 3 times, came up with the same result, and every time everybody said this doesn't make sense. So it was sent back to the engineering team, and the results was they simplified the process. They ended up removing the problem area. We removed that vessel. It optimized the process, so we not only saved millions of dollars in the construction costs, we optimized the operation, saving the operation of the facility, hundreds of thousands of dollars a year throughout the life cycle. So one of the benefits of the risk studies with the HAZOP, with the CHAZOP included, is that they almost always save money. So the next steps, so to start a CHAZOP, so once we get the call, I'd be asking for a system architecture, corporate risk guidelines, bill of materials, network communication paths, critical control, and a number of other documents. Will determine what team members really need. And again, a CHAZOP is generally fairly small. We would need, we'd like to have somebody to represent maintenance and operations, somebody from the control system team or the implementation team is a minimum, and then anybody else that's outside. If we do happen to get into mechanical or process type issues, we can bring those people in on an as needed basis rather than having them sit there. Along with the preparation, we'll determine, work with the facilitator to determine what method works best, what kind of results, or what, identify what the goals are early on so that we can determine the best method for that. And once we have the documentation, we'll start noting. So we'll look at networks, the system architecture, the process unit, building racks, and then we'll start coming up with relevant deviations to try and streamline the process. So we want to do as much prep upfront as we can to try and reduce the actual study time and the meeting time. So again, we'll develop what-if questions if that method is chosen to be used. And again, I want to thank you for coming and listening to me. And if you have any questions, please feel free to ask.
Okay, so as I mentioned at the beginning of the webinar, if you do have any questions, just type them into the questions tab on that control panel. And we've got some coming in already, so we'll just get started with those. So the first question is, would I be correct in assuming that whatever is done in a CHAZOP is generally covered in a software and hardware acceptance test of the DCS system?
Good question. Partially, yes. So a CHAZOP is at the front end. So a CHAZOP will identify issues early on. And you may want to there may be some recommendations that need to be included in the testing, in the software, hardware, or FAT testing at the end of near the end of the design phase that need to be accounted for. But the CHAZOP is not a substitute for that. it will identify issues that need to be rectified throughout the design, and then hopefully be able to. But but you still have to do your FAT and everything at the end. I hope I answered that.
Okay, the next question, what is the probability of a fat finger mistake?
It's very difficult to assign a probability to human error. They do happen. You know, even if you're just typing out a report on the computer, we make typos the same way. But the probability, it has happened. Personally, I've, from pushing, like I said in the example of putting in a set point of 700 versus 7,000, that actually did lead to an incident. There were other contributing factors to that, along with it, but it did lead to an incident. I've also seen ESD buttons pressed and plants depressured by mistake. So it comes down to human error. So, you know, we do our best as humans, but we generally, we are prone to making mistakes. We're generally, like NASA studied, and you know, an astronaut flying a mission on the space shuttle will train for, you know, solid three weeks, and you know, and they throw scenarios at them, life and death scenarios, and more often than not, the astronauts would make the wrong decision. So as humans, we generally don't make the right decision in life and death situations. So, but more importantly, anything that we can do to make life easier and reduce the potential of these types of mistakes, we should identify them and see if we can't you know, make life easier, make life better.
Okay, thanks, Sam. Next question, is there any training available for individuals who are interested in facilitating or leading a CHAZOP?
Yes. Right now, Autopro doesn't offer that type of training, but there are training opportunities available. I can look them up. If I can send this answer out after here. I just can't think of any off the top of my head right at the moment. But yes, there are training programs.
Okay, we don't actually have any more questions in the queue right now, so if you do have a question, feel free to type it in and we'll get it answered for you. And as I mentioned at the beginning of the webinar, this does qualify for professional development credit, so you will be receiving an email afterwards with a certificate of completion that you'll have for your PD records. And that email will also include a link to a web page where you can watch the entire webinar again. And at the conclusion of the webinar, you will see a poll, a survey pop up that just asks you a few questions about what the value of it was, how was the software platform, that sort of thing. And we do appreciate if you can take a couple minutes to fill that out. It just helps us to kind of guide what we do next for webinars and make sure that we're putting on sessions that are the most value to you. So we're going to leave the session open for a few more minutes here. If you do have any questions, feel free to type them in. And even if you type in a question and we don't have a chance to answer it now, we will send out, as Sam mentioned, we will send out written answers to the questions. So once again, apologies for the late start this morning or this afternoon. We had some technical issues here that we'll have to get sorted out, but we do appreciate your patience. And another question just popped in. Is it possible to share the presentation? So yes, as I mentioned, you will receive a link to a page where you can watch the webinar again. And we may share the slides. I'll have to just consult with Sam to see if we want to actually share the individual slides, but you will at least be able to watch the recorded version of the webinar. Okay, another question here for Sam. Is there any industry code or regulation for CHAZOP requirements?
Good question. I get asked that from time to time. Specifically, no. However, in Canada, there is a requirement for workers to understand the risks associated with their job. So operators, they should understand and be able to have an opportunity to learn and understand what the risks are, and they need to be identified. So much like a job hazard analysis, you can think of a CHAZOP as somewhat of an extension of that. So if there is a risk or there is a problem, then we should be able to identify that, and that's what it does, and it helps. But as for a specific code or regulation requiring a CHAZOP, no.
Okay, next question is, how do you justify a CHAZOP if a HAZOP is done at a regular interval?
Well, a HAZOP generally, they're recommended to be done at regular intervals. The IEC standard and a few other recommend approximately every 5 years. A CHAZOP may not have to be done quite that often, but the difference between a HAZOP assumes that the control system is operational and it is working, whereas a CHAZOP looks beyond that and into the control system and determines and looks to see if your network, your remote IO network or your peer-to-peer networks, what happens if they fail. Do you have to do it regularly? No. But it would be a good idea to do it as part of an upgrade or an expansion to an existing system.
Okay, throughout the presentation, the examples of a CHAZOP recommendation show the need to install a redundant item. Would it be safe to assume that the current thought is to install a complete redundant system that could prove very costly?
You don't need redundancy everywhere, and it's true. What we're trying to identify is if there's a critical area, for example, like a process that's looking at the feed into your facility, that would be critical. Without that, you'd be down, lost time, all of that. But if you look at, say a packaging unit or some unit where there's lots of storage, like truck loading, for example, if there's enough storage there, it may be okay to have, an outage isn't a big deal, and those can be identified as well. So if it's a priority, spend the money where the priorities are, and the identified low priorities or the low risk areas, you don't need to spend the money, and that's what we're trying to convey through a CHAZOP.
Okay, so that's all the questions we have in the queue again. So as I mentioned, if you do have any more questions, please feel free to type them in. We'll leave the window open for a few more minutes here. But for those of you who don't have any more questions, thank you very much for joining us this afternoon. And watch your email for the certificate of completion and the link to the recorded webinar. So thanks again and have a great afternoon.